Good afternoon. My name is Mark Erikson, and today I am very excited to talk to you about a guide to React compiler rendering. A few quick things about myself. I am a senior time travel engineer at Replay, where we've built a time-traveling debugger for JavaScript. I will happily tell you all about the really cool things we're getting to build there. I'll touch on a couple of them right at the end. I am an answer of questions. I will answer questions pretty much anywhere there is a text box on the internet. I am very deeply involved in the React community and spend a lot of time moderating places like the React Reddit or the React Flux Discord. I am a collector of interesting links. I will collect all kinds of interesting links and paste them in response to other people's questions. And I do a lot of that as part of the This Month in React podcast. I write extremely long blog posts. Usually they're about React and Redux and JavaScript. I actually just published a new post about an hour ago that is my experience, thoughts, and opinions on using AI for development. So if you want to read 15,000 words of stuff inside my head, that's on my blog right now. Go have fun. And I am a Redux maintainer. I have been maintaining the Redux state management libraries for just about 10 years now, which seems incredible at this point. But most people know me as that guy with the Simpsons avatar. It's become my trademark at this point. So why are we talking about React rendering today? Out of curiosity, how many of you folks actually use React either in your job right now or side projects or something like that? Okay, just about everybody. Good. If you don't use React, then why are you even here in this room? I am a very big believer that it is always important to understand the fundamentals of the tools that you're using, and I think that's even more important in the age of AI. And I've spent years and years answering people's questions about React, and I see a lot of very common misconceptions about how React actually works. And clearly it's possible to use tools like React without fully understanding every detail, but it's also important to actually have the correct understandings about how these tools work. And this is especially true in this case because the new React compiler actually flips some of React's default behaviors upside down. And so if you don't have a good grasp on what the defaults are, then you're not going to be able to understand what the compiler is actually doing for you. So really my point through all this is that this is science, it's not magic, and we're going to break some of these things down. So most of the conferences that I get to speak at are specifically focused on React or JavaScript. This conference is a little outside my usual venue. I suspect we probably have a lower percentage of purely front-end focused people here. Out of curiosity, how many of you would say that you feel like you are an expert in how React works? Okay, nobody. Great. How many of you, let's see. How many of you have at least heard of the React compiler at all outside the title of this talk? Okay, about half maybe. How many of you think you know what the compiler actually does? Half a hand. How many of you have actually tried installing the compiler in a project? One person. Cool. Okay, so hopefully this will be new and reasonably interesting material for most of y'all. Now, they actually gave me 50 minutes for this slot, which means I get to talk a lot and give a lot of details, which is what I really love doing. So the shorter version of this talk already has a bunch of info on React fundamentals. Because I have extra time, I have inserted bonus material on React fundamentals. Not all this is strictly necessary for understanding how the compiler works, but it's relevant, and as I said, it's important to understand the fundamentals, so you're getting the extra material anyway. So we'll spend some time focusing on how React rendering actually works. We'll talk about some of the existing options that React has for trying to optimize performance. Then we'll dig into the compiler itself. What is it doing? What does the output look like? Why does this actually speed things up at all? And then we'll finish with a few thoughts on how this actually changes the way we think about using React. The slides are up on my blog, blog.isquaredsoftware.com. QR code goes directly to the article, or you can go there, and I think it's like the third link from the top at the moment. All right, so all the way back to the beginning. What is rendering in the first place? So I would say that rendering is the process of React asking your components, what do you want your piece of the UI to look like at this point in time? And so normally that is based on the current props and the state that this component has to work with, the current data that it has. So when we write React code, we write this angle bracket JSX syntax that looks a lot like HTML. But when we write that initially, that is going to get transformed at build time into these react.createElement calls. So it's just a direct transformation. And so the createElement call accepts an argument that is the type of the component to render, the props that you want to pass in, and then the children that you want to nest inside that component. And createElement just returns an object that is the type, the props, and the children. So it's just saying this is a description of we want the output to look like this. So elements can either contain references to a component type, like my component here, or they can refer to host elements that are built in. So for React DOM, that would be tags like a div or a span or a button. In something like React Native, that might be one of the native view types. So as React is rendering, it's going to walk through the component tree. And for each of your components, it's going to call that function, ask it to return some nested tree of element objects. And then once it's gone through the entire tree, it's going to diff the current full tree of element objects against the previous tree of element objects. React does not actually look at what's in the DOM right now. It's just comparing these two trees of objects to see what might have changed. If you've ever heard the phrase virtual DOM being thrown around, that's really just a fancy way of saying these element objects that describe what we want the UI to look like at this point in time. So when we actually do this rendering process, React splits this work into two major phases. And the first phase is what we call the render phase. And that's where it actually goes through the whole tree of components, calls each of them, collects the output, and does the diffing. Historically, this has been one big synchronous loop, start to finish. But in newer versions of React, it can actually split that work up into smaller steps. There's certain portions of React rendering that will now tell it this is a low priority render. And when it does a low priority render, then it might render some components for a few milliseconds, pause, give the browser a chance to process some updates, maybe wait to see if something higher priority has come in, and then picks up where it left off. Once React has actually gone through the whole tree, and it's established if there are any changes that need to be applied to the DOM, then it runs what it calls the commit phase. And the commit phase is actually updating the DOM as well as running some of the class lifecycle methods or some of the newer layout effect hooks. And it does all this in just one big synchronous block, start to finish. And then if you're familiar with the use effect hook, which please use that as rarely as possible in your code, use effect actually runs on a short timeout. So the commit phase completes, there's a little bit of a timeout, and then React runs through all the use effect hooks. And again, this is to give the browser a chance to apply some updates in between. So every single React render is going to start with some form of a set state call. So React just sits there until you tell it actually update this value. And so there's multiple ways to trigger some update. The default ones would be the setter functions from the use state hook or the dispatch function from the use reducer hook. And then if you're using an external library like Redux or ZooStand or Jotai, they can trigger updates with the use sync external store hook. There's also the older style class component updates, as well as if you call the root render at the top, it'll act kind of like a set state for the root component as well. Okay, this is a very important slide. Please pay attention. React's default behavior is that when a parent component renders, React just recurses through every single component under that and just renders all of them by default. So if I did a set state in the app component, then all 4 of these other components under here would render as well. Inspiration, a couple different fancy texts, the copyright. If I did a set state in the inspiration component, then these 2 components under there would render. So just by default, you start with the component that did a set state, and then you just keep on going for every single component under that. And as we'll talk about, React doesn't care whether other things changed. It's just going to recurse through the entire tree. Now, there is a bit of a distinction here that when we say render, this doesn't automatically mean that there will be updates applied to the DOM. The React team early on tried to say that we can think of rendering as if we were redrawing the entire UI, but what if the picture we're drawing is the exact same picture as last time? Like there's nothing that actually needs to change, right? So as React is going through and collecting these elements and diffing them, it's entirely possible that every component is going to ask for the same equivalent output that it asked for last time. And if nothing needs to change, then nothing actually has to get applied to the DOM. So we can say that a render for a given component was wasted if it returns the exact, like the equivalent output to last time. You might have seen the phrase that with React, your UI is a function of the props and the state. So if you have the same data for a component, it probably ought to be asking for the same output as last time. So if the data hasn't changed, the UI doesn't have to change either. It's also worth noting that rendering is not a bad thing. Like this is literally the process that React uses to decide if something needs to change. So, rendering is just how React works. React also is known for having some kind of strict rules about how you're supposed to write your code. And if you break these, the app might not necessarily fall apart right away, but you might end up with some subtle bugs somewhere. So you should probably follow these. So for example, you definitely should not mutate incoming props coming into a component. You also should avoid creating new random values while rendering. If I make a new object inside of a component, then I could, in theory, mutate it because it hasn't been exposed anywhere. No other part of the system has seen that value. Strictly speaking, console logs are a side effect, but they're obviously not one that's going to hurt the runtime behavior of the application. And then there's some weirder patterns that are sort of kind of okay. Strictly speaking, you can lazily initialize a ref object while rendering. You're really not supposed to trigger network requests while rendering unless you're doing suspense-like things, in which case it's totally okay. You're also not supposed to call set state in the middle of rendering unless you very carefully put some conditional logic around it, in which case it's also okay. So there's some weird edge cases around here. But the React team had talked for years about this idea of the rules of React, and they'd even written a lot of them down, and they kept insisting people should follow them, and a lot of people didn't follow them, but my program runs just fine. Why should I care? You're about to care in a minute. A couple other bits, and again, this is kind of deep dive info that you don't necessarily need, but this is useful for the mental model. For both function components and class components, React actually stores the data in these internal objects called fibers. So an element says, here's what I want things to look like, but then a fiber is like the actual internal instance of that component. So it stores a reference to the type and the current props and state and the children and some linked lists that React can use to iterate through the whole component tree. If you've ever heard the term React fiber, the React team rewrote all the logic, what was it, version 16 many years ago. So this is essentially just the current internal implementation of how React works. So React has looked at your components and it's called them and it's done some diffing, and now it's trying to figure out, how do I actually update the content in the page? And doing that diffing can be very expensive, so React tries to make some simplifying assumptions about how to do that. And one of the assumptions that it makes is it checks the actual type of a component, like the reference to the function or class type, at a given spot. And if the type that you asked for in that output location changed, it just assumes everything under there is going to be different. That means that if you change the type of a component in a given spot, React will actually just destroy everything that it created there and then recreate everything under there from scratch. There's a very common mistake that I've seen a lot of people make over the years. You notice in the example on the left that we have this function child component being defined inside of the parent component. That means every time the parent component runs, we have a new reference to child component. And as far as React is concerned, that means it's a completely different component. We have never seen this before. And every time we render, we will just destroy the old child component and recreate everything inside of it from scratch. That's usually bad for performance. You probably don't want to do that. So just general FYI, unrelated to any of the compiler stuff, please never, ever do that. Please always define component types as their own standalone top-level functions. I've seen a lot of people make that mistake. Similarly, React allows you to define a field called a key when you render a component. This is essentially defining a unique identifier within the siblings to each other. Now, most of the time we use this for lists, so that if you have a list of items and then maybe you add or remove or reorder them, React can properly identify which ones are still alive, which ones need to be moved. Otherwise, some weird behaviors might happen. So if you are writing keys, please try to use actual fields from data. Please never, ever, ever, ever try to use random values for keys, because then just really, really bad things will happen. A couple other bits. As I said earlier, every time you start a render, it's because you called set state in some form. If you have multiple set states in one event loop tick, React just sort of batches all of those together into a single render pass. The behavior on this used to be a little different. If in earlier versions of React, 17 and earlier, it would only try to do the batching when you had set states inside of like a click handler. And starting with React 18, they just now always batch updates all the time. So in this particular example, in React 17, this would have, I believe, 3 different renders. So the first 2 would have gotten batched into a single update because it was in a click handler. Then you have the await. Then the set counter 2 triggers a second one, and set counter 3 triggers a third one. But starting with React 18, it just says you've got 1 event loop tick up here, 2 set states, 1 render. You've got another event loop tick down here, 2 set states, 1 render. And so this is the behavior that React defaults to today. Question?
Why was set count to 0, 1 but not 2, 3?
So strictly speaking, what React does is it just sets an internal flag, essentially like should batch true. And so every time you call set state, it would push it into a queue. And then at the end of the loop, it says, okay, we've got 3 pending updates. Let's just do all those together in one shot. And so prior to React 18, if you did a set state that was outside of one of the event handler callbacks, that flag was set to false. And React just said, okay, there was a set state, render. There was a set state, render. So implementation-wise, it's pretty simple, but they just made an intentional change to try to do batching all the time by default, starting with 18. One other common mistake that I see people make all the time is you try to call set state with a new value, and then you try to use the seemingly new value on the next line, and it doesn't do what you thought it was going to do. Now, half the time, this is people just trying to do a console log with the value just to, I guess, prove that it's there or something. So why doesn't this work? The phrase that a lot of people use to describe this is that they will say that the rendering process is async. Strictly speaking, it's not async, but it's sort of async from the point of view of this code. I said just a minute ago that when we do the set state, it's essentially just pushing an update into a list of updates to be applied later. So when I call set counter right there, it's queuing up an update. It's not actually executing the update right away. And because this is JavaScript and we have closures and we capture existing values, that line of code can only see the value that existed at the start of this render anyway. So in that example, that counter value can never be 1 because we captured the 0 that already existed. Okay, so now getting into the part that actually matters for the compiler. React has a couple different ways to let us try to optimize the behavior of our components. And so the biggest one is being able to skip rendering components if the incoming props have not changed from the last time. And there have been a couple different ways to do this over the years, but the current tool we have that React gives us is this react.memo method. How many of you have ever heard the phrase higher order component? Okay, less than half the group. Higher order is a fancy way of saying it's like a wrapper. So like a higher order function or a higher order component really just means it's a wrapper of some kind. So react.memo is a higher order component or wrapper. You pass in the actual component that you have, and it essentially creates another component wrapping that. And what react.memo does is it just automatically checks, have any of the props for this component individually changed since last time? And it uses what we call a shallow equality comparison, which means it's going to individually compare all the fields in 2 different objects. So does previous props.a look the same as current props.a? Does previous props.b look the same as current props.b? And only if at least one of those fields has changed will it go ahead and continue on to render your actual component. So you notice that this is something that we have to add specifically to our own code to say that I want to wrap and optimize the component. Yes? Congratulations, that's like 3 slides ahead. Oh, okay. No, that is an excellent question. Yes. We will get to that part. Now, there is one other trick that you can use to trigger some of the optimizations, and this is something that almost nobody using React even knows exists. So we said earlier that we write the angle bracket JSX syntax that gets converted into create element calls. Every time we render, React is going to call create element, create element, create element. Those return new objects. They may have the same contents, but they're different references than last time. Well, if we actually keep around some of the element object references and we return the same reference as last time, React looks at it and says, oh, this is like not just the same, it's literally the same element object that you gave me last time. Okay, great. I'm just going to pretend that I don't have anything I have to change here at all and skip rendering this component in exactly the same way that React.memo would. And so there's a couple ways we can make this behavior kick in. If you've ever used the children prop and included that in the output, then if I were to do a set state here, the children reference is the same as it was the last time. So React gets to here and it says, okay, update the div, update the button, same content, same object, don't do anything, bail out. And it doesn't matter how much more content you had inside of there, it just skips the whole thing. Similarly, we can use the use memo hook and memoize the creation of individual chunks of the JSX, and we'd have the same behavior. So I like to think of it as React.memo is being controlled by the child component. So I have specifically said I want this component to be optimized if possible. But the element reference check is sort of controlled by the parent component. So in that case, use memo in the parent was what determined that we are optimizing this piece of the output. Now, one of the most common misunderstandings I've seen for years is people assume that React only renders the children when the props have changed. This is not true. React does not care if any of the props have changed. Remember I said earlier in that slide that was very important that React just goes recursively by default. Every single component could have the same props in the same state, and React wouldn't care. It would just go all the way down by default. The only time that the props references changing matters is if we're actually trying to optimize this behavior at all. Otherwise, there's no checks. It just says, here's your input, what's the output, and then it does the diffing at the end to see if anything has to update. Okay, so as we just heard a minute ago, a lot of people have asked, why doesn't React do this by default? Why don't we just wrap all our components in React.memo? Why don't we wrap literally every single handler function in useMemo or useCallback? And the answer is you totally could do this. And in fact, I've seen a lot of people argue that you ought to do this. Historically, the React team has advised against doing that for a couple different reasons. One is that it's really only beneficial if some pieces of your component tree are kind of expensive. And in some cases, depending on what the props are, it's possible that every time this component renders, it's going to get at least one different prop every time, in which case the comparison always returns false and it always re-renders. So if the comparison is never going to actually save you any time, why spend time doing the comparisons in the first place? Plus, it's a lot of work. How many of you have tried to manually put some use memos or use callbacks into your code? Was it fun? Not really. Not really. So the answer is you could. And I've seen some people argue that the benefits are worth it, but it's a lot of extra work. There's some cases where it will never actually provide a benefit because of the structure of the code. So the React team's advice has been don't do it as the default. Specifically, wait to see if your app has performance issues, then do some profiling, then look for specific components that would benefit from this. And that is where the React compiler comes into play. Straight from the docs, the point of the React compiler is that it will automatically optimize your components and your application at build time. And in fact, they even point out that doing that work by hand is tedious and easy to make mistakes and a lot of extra code. So the React compiler does all the work for you. All right, let's talk about how that actually happens. What does the compiler actually do? The compiler essentially does three things. For every one of your components, it's going to read the actual JavaScript code inside the component, and it's going to figure out which props and values and variables and pieces of data does your component actually use, and how does it use those values. And then it's going to track the dependencies to figure out for both the JSX elements and the other calculations inside the component, which output depends on which values. And then it actually rewrites the logic of your component to separately memoize each bit of the behavior. So let's look at an example. Here we have a very simple component for a user card. It accepts a user object and an onFollow click handler. We format the name, which is probably just first name plus last name, whatever. It's an example. We stick the combined name in the output, and then we have a button with a click handler that calls the follow prop with the user ID. It's pretty straightforward. So what happens when we run this through the compiler? I'm sure it'll be nice and simple. Oh, dear. That looks lovely. Why are there all these dollar signs in here? Did someone spill some jQuery in this component? Like, what is this even? Okay, the good news is it's actually not nearly as scary as it looks. We're going to break this down. If you looked at the output from the compiler, you would see that it's basically the same 5 or 6 lines of code repeated over and over and over. And it's the same pattern every single time. All it's doing is it looks at the inputs for a given piece of data, and it checks to see, have any of those inputs changed? If they've changed, then it recalculates that bit of code, and it saves both the inputs and the result into some kind of a cache. And if they haven't changed, then we just look up the value out of the cache, and we use that instead. That's all this is actually doing. So in this example, format name depends on 2 things, first name and last name. So we check to see, has user.firstname changed? Has user.lastname changed? If they changed, then rerun the output function and save first name, last name result. If they haven't changed, then just use the value we calculated last time. That's it. Wait, where have we seen this before? Oh, right. That's what the use memo hook does. It's exactly the same thing, except that the use memo hook is hiding those comparisons for you inside. All we've done is we've actually converted this into, technically speaking, more lines of code and uglier, but it's all right there. Like that's pretty readable code, right? But also that's not actually the code the compiler generates. Same thing if we have some JSX. So here we were trying to insert the name into a header. Same thing. It's JSX. It's an element. This is a value. We can save that result for later. Same thing we could have done with a use memo. Yeah, what's up with all the dollar signs? Well, this actually kind of goes back to the jQuery thing. JavaScript allows you to use certain characters in variable names, including underscores and dollar signs. And certain libraries like jQuery and Lodash decided, you know what, we are going to grab one of those variable names for ourselves. So you will write it everywhere. And in this case, the React team said, you know what, rather than calling this variable cash or something, we're just going to call it $, because it's short and it's legal. So we're going to use that. So everywhere you see $sign in here, just mentally search and replace that with the word cash, and it's the same thing. But you'll notice this is an array. So instead of fields like first name and last name, it's indices, 0, 1, 2, etc. But this is really the same thing, just renamed. Like, it really isn't actually all that scary. Although, what's that _C thing up there at the top? So, starting with React 19, React actually now includes a new special hook that in theory is called useMemoCache. But for short, they just call it C or _C or something like that, again, just to make the name short so they don't have to keep repeating the same word all the time. What does this hook actually do? Well, the compiler counts how many things am I going to have to save for this component, and then it just says, make me an array that is that big, and that is the size of the cache. That's it. It's just a use memo that returns an array, the end. So by the time the compiler has gone through all the different pieces of output in this component, it gets down to the end where you have your final return structure, and it's the same thing all over again. What are the different pieces of the output? We assemble them one more time, we return the final result, and that's it. So again, it's just the same few lines of code being repeated to build up all the pieces of the output for this component. So how does this actually make anything better? Anyway, well, one is that let's pretend for me that format name is like incredibly expensive to run. I mean, like we had to add these 2 strings, so slow. By having it memoized, it's only going to rerun if the inputs actually changed. And you know, we saw earlier that we were calling create element, you know, dozens, hundreds of times per component, depending on how much output you have. Creating new objects is pretty cheap, but it does add up over time. And so by memoizing the JSX, we're at least getting to skip calling create element most of the time. But those are actually kind of side benefits. The real actual time savings here is that if a given section of JSX didn't change, we're going to reuse the same element object, and at that point, that reference comparison trick comes into play, and React will skip rendering that child component and everything that was inside of it. And that's the actual real savings right there. It's not just about skipping 1 or 2 function calls or some element objects. It's about skipping the work of trying to check and update large portions of the component tree. So what happens if you're using React context or something like Redux or Zeusstand or some other external store? Same basic thing. So here I've got a component that is reading a couple values from a context object, and say we're using some of that in the styling and some of the in the output. It's the same thing. It just says here's some values that you're using, which portions of the logic and the output depend on that, and it assembles the final result. Same memoization pattern. Similarly, if you're using React Redux, here I've got a selector that depends on a prop, like category ID. I've got another selector that was defined outside the component, so the reference isn't changing. This is actually a bit of an improvement. You notice here, I am creating a new anonymous arrow function reference every time this runs. And that's fine. React Redux lets you do that. Here, you notice it actually saves the reference to the selector function. So we only actually recreate this function when the category ID field changes. So that's actually an improvement on just writing that by itself. But again, it's the same principle. Look at the inputs, memoize the result, only recalculate when those change. What if I already have use memo or use callback inside my component? The React compiler actually uses this as a signal that this piece of code is something that should be memoized, and it will actually replace use memo or use callback with its own preferred pattern. Now, this also brings up an interesting question about context performance. Quick check. How many of you have used context to pass around data in your applications? Okay, a lot of people. As Redux maintainer, the number of times I have heard someone ask over the years, should I use context or use Redux? I cannot tell you. That counter overflowed years ago. And a lot of the issue has been that context was not designed to pass around large amounts of data. It's really designed to be like more of a dependency injection tool. And one of the weaknesses of context in terms of performance is that when I render a context provider high up in my tree, it accepts a single value as a prop. Now, that value could be a very large object with a lot of different fields, and maybe this component over here reads context value.a, and this component over here reads context value.b. What happens when I do an update up here and I update the a field? Every component that read from that context provider still sees a new object with a new reference, and it's going to re-render. And maybe we even just kind of skip from here to here, but then React keeps rendering everything below those components. So everything that read from the context is going to re-render, and then everything nested inside those components is going to re-render, which is why if you have, say, a context provider in your root app component and your entire app reads from that context, you're essentially making your whole app re-render all the time for everything. With the compiler, it doesn't change the basics of the behavior. You put in a new value, every component that reads the context will still render. But let's say we get to this component that only cares about context value.b, and that value did not change, which means the input to its children did not change, which means the compiler optimizes everything and then it just skips out and nothing else renders over here. So the compiler does help make context more efficient, not because context works differently, but because it's actually skipping out on components that saw values that haven't changed. Didn't we say something about like not mutating things? Wasn't that one of the rules of the React? Sorta, kinda, but also this is the compiler outputting the code. So clearly the React team thinks this is okay. Fine, whatever. Okay, a couple minutes left. We are right on time. Wonderful. Let's go back to the mental model. I said earlier that a lot of people have misunderstood and thought that my components only render when their props changed. And we said that's wrong. React just recurses by default. It doesn't care about props unless you were trying to optimize in the first place. Guess what? The React compiler actually makes this a reality for the first time. If you have the React compiler installed in your project, you can think of this as the new mental model for how React is going to work in that project. The parent component will render, and if the pieces of data that became the props for a child haven't changed, it's the same element object reference, and React will skip it unless those actually changed. So, how do we actually teach this? And this goes back to my very firm belief in the fundamentals. imagine a couple years. Sorry, question? That is another way that it comes into play, yeah. Yeah, one of the reasons why I've seen people say in the past that you ought to use memo, use callback, everything, is trying to make sure that if a value gets or a callback gets passed around, you're guaranteeing it's the same reference and you don't accidentally trigger either renders or use effects somewhere down the line. Yeah. So, mental model. Let's imagine a year or two from now where maybe the compiler is more in widespread use. More frameworks have turned it on by default. More projects have gotten around to actually installing it and turn it on. And then let's say a brand new developer comes in and joins your team and is their first React project, and they're so excited. And they learn React on a project that has the compiler already enabled. And then they go to another project that doesn't have the compiler enabled. And I can foresee that it's possible that by learning React and using React in practice when the magic was enabled, they might actually not really understand that the compiler is there and doing some of that magic work for them. And if they go somewhere that doesn't have that enabled, they might make some mistakes along the way, like maybe not realizing you need to have use effect dependency arrays or something along those lines. I actually have already fought this battle. And this is a lot of why I said I'm a very big believer in the fundamentals. How many of you are familiar with the difference between the original Redux core and Redux toolkit at all? Oh dear, a very small number of people. How many of you have at least used Redux in any way, shape, or form? Slightly more people. Okay, does the word create slice mean anything? Not enough people. Oh dear, that's okay, Drat, that's an entirely separate talk. Anyway, so Redux has always relied on immutability, that when you do an update, you must make copies of the existing data objects, and then you modify the copies, not the originals. React relies on this as well. There is a wonderful library called Immer, and Immer is designed to simplify the process of making immutable updates. If you've ever seen something like return ... state ... state field ... state field nested ... that's writing an immutable update by hand. It's ugly, it's slow, it's hard to read, it's very easy to make mistakes. And so Immer is a library that makes the process of writing immutable updates much simpler. I do not have an example in here. It actually lets you write what looks like mutating code, state.value equals 1, 2, 3, and then it traps that and it converts it internally into a safe immutable update. And we use Immer by default in the modern Redux toolkit library, which, by the way, is the correct way to use Redux today. Please migrate to Redux toolkit right now. But again, this is a case where there's magic happening inside of our create slice method. And if you don't already understand that immutability is important, you might not realize that Immer is there and doing this magic work for you. So in our docs, we very clearly teach the core concepts of immutability first, and then we say, and then the Immer is doing this magic for you. All right, I am about out of time. You can try out the React compiler today. The docs have instructions on how to actually go use it. There's a nifty interactive playground where you can paste code in and see how much the compiler will radically transform it. It does currently rely on a Babel plugin, but the React team is working on porting that to Rust. By default, it needs React 19 in order to work properly, but there is backfill support for React 17 and 18 as well. I am out of time, but one pitch for my day job, really fast. I said earlier I work at Replay, where we have a time-traveling debugger for JavaScript. Our original product was the time travel browser DevTools that lets humans investigate bugs deeply. We now have an MCP that lets agents investigate as well. It gives agents the ability to time travel debug and understand what went on in a front-end application. I've spent a lot of time making this better. I've written some blog posts about how it has enabled agents to find bugs in just a matter of minutes. I would be very happy to show you how cool it is. So that's all I've got. Slides are on my blog. Please come check out Replay MCP as well. Thank you very much.